Okay, so now we're on problem 5. This eyeball problem about balancing center free sets. So instead of finding infinitely many n, we're not required to find all n. So that we need to show that all of those that we didn't include will fail. So far we have shown that all n works, and it seems that n equals 4 equals 6 doesn't work. So we probably want to show that all even n fail. So last time when we showed that infinitely many n works, we can use an intuition that remember last time I used the approximate equal sign instead of equal sign. And when we want to find all n, we need to be a little more rigorous. So this happens. So balance means that each pair of points, we need a point to cover them. So by covering them, we be equidistant to them. And center free means that each point, like this point, cannot cover 3 points at once. So you cannot you can have a point here that's also equidistant to.
So that kind of leads to a bijection argument, because each point you are trying to say you cover is corresponding to one pair, right?
Yeah. Except that it can cover some more pairs, but of different distance. And I'll go to that later. So here we use a technique called double counting. So first we look at the perspective of pairs. So say there are 2k choose 2 or 2k squared minus k pairs. And
so that is what every pair of numbers in a set, right?
Yes, yeah. So there are this many pairs. So by Pinnacle theorem, there needs to be a point that covers at least this number of pairs. So otherwise you can take a scaling function. This gives us k.
What do you mean?
So basically it means that
what do you mean divided by 2k? Right.
So I guess you just think about a concrete example with some numbers. So if we have, say, 5 pairs or
6 pairs.
Or sure. Yeah, plug equals 2. So let's say you have 6 pairs.
6 pairs. So you have 1, 2, 1, 3, 2, 3, 1, 4, 1, 5, 1, 6.
There will be 6 points.
There will be 6 points. And then 1 to 5, 6. So as I said, each pair needs a number to cover a point to cover them. So say 4 covers this, say this 5 covers this, say this 2 covers this, etc. So there will be 15 numbers that appear here, and there are 6 different numbers that appear. So which means at least one number must appear 3 times. So this is kind of generalized version.
So this is called the pigeonhole principle.
Yes. So we said basically there must be a number that appears k times here.
And this is going to be a good candidate to be a center, right? Because it covers too many points.
Yeah, it might cover 20 points.
Right.
So
I think you might want to make this clear. This is not 1, 2 are numbers. Those are points, right?
yes,
You might want to say P1, P2.
sure. P1, P2.
P1, P2 is covered by P4, for example.
Yes.
Right?
So yeah, so one point must appear at least k times in this box.
So that means that pair covers at least k. That point covers at least k pairs of numbers.
Yes.
Right?
So let's not look from perspective of point. So see how many can you cover. So say we have a really big point here.
So that's your magical point that covers k pairs.
So,
right?
yeah, okay. So you say can cover this pair, etc. So notice that if it covers this pair, it's basically taken out because
2 points.
2 points are already taken out. So besides this point, there are 2 k minus 1 other points. So if
Besides itself.
yes, so
Right.
if we take out k minus 1 pairs, there are only 1 point left, and it cannot possibly cover that. So which means that a point can cover at most k minus 1 pairs. So yes. So on one side, there's a demand for a point that covers k pairs. On the other hand, no point can cover k pairs, which means that we should contradiction when n is even.
I think over here you want to explain more carefully why the pairs are distinct. It's basically what you said earlier, that this is the finishing touching detail. You cannot have a point that covers 3 equal distance points. Because if that happens, you already have a
I
center.
think the easiest way to explain that would be if we just look at covering k pairs, right? You have one point that covers k pairs. There are only two k minus one other points, right?
Right.
So if you cover k pairs, there have to be two pairs that have an overlap,
Right.
right? Because if all of them are separate pairs, then you just need two k points, but you only have two k minus one.
And if you have two pairs that have an overlap, one point in common, then your point.
Then the distance has to be the same.
Yeah,
So
so
it's a
pi to pj and to pk.
Yeah.
And then it means it's the center of these 3 points.
3 points, right? Yeah. So basically, from your earlier comment is you cannot have a center covering 3 equidistance points. So
Yes.
all of these pairs must be covering different points, and that easily leads to 2k different
Other points, but there are only
Points.
two k minus
but there are only 2k points,
Yes.
right?